So we looked at the relationship of KW and pH. And so in this section what we're going to look at is the specific pH scale and how we can calculate pHs or concentrations from pHs when they're not 1 times 10 to the minus whatever. Okay, so as we said, as far as strength goes, 7 is neutral, and then a base, and if you think about the pH scale, the pH, the farther you get from neutral, the farther you get from 7, the stronger it is. So when acids go this way, so the stronger acid is going to be the lower number because it's farther away from 7. So 6 is weaker than 5 because it's closer to neutral than 5. And so 0 is the strongest acid that you can have. Whereas bases make a lot more sense because as they get away from 7, they're going up in number. So a pH of 14 is a strong basic solution. So everything greater than 7 is a base, and everything less than 7 is an acid. So the pH scale is a log scale or a logarithmic scale. And so in a logarithmic scale, you have the same number of places after a decimal as there are digits in the original number. For example, if you have a hydronium concentration of 1.2 times 10 to the minus 5 molar, how can you find the pH? Well, we know that the formula for pH says pH is the negative log of the hydronium ion concentration. So the pH is the negative log of 1.2 times 10 to the minus 5. So if you do the little minus sign on your calculator and then hit your log button, and then it'll open parentheses for you, and you put 1.2. If you have an EE button, put E minus 5, okay, and that should give you 4.92 as your pH. Alright, so try that a couple of times, make sure that you get this. Now if you don't see an E button and you've got a 10 to the X button, you can do 10 to the X minus 5, okay, and that should put the minus 5 up there, and you got 1.2 times, 1.2 times 10 to the minus 5. But you've got to put the negative log, and you're not subtracting, it's the sign symbol, negative log, and then times however you put it in your calculator to make sure you get the full 0.92. Alright, since it's less than 7, this is an acidic solution. If you have a pH which is 8.5, how can you find the hydronium ion concentration? Well, again, our original formula is pH equals a negative log of hydronium ion concentration. So 8.5 equals the negative log of H3O plus. Now, you're going to have to do the antilog of your 8.5, and so what you're going to do is you're going to say 10 to the X, and you're going to do the minus, since it's antilog, you're going to say 10 to the X minus 8.50, and that should give you 3.2 times 10 to the minus 9. And since 8.5 is greater than 7, you know that that is also going to be a base. So put that in your calculator and make sure that it's going to work. So I'm going to do it too. Make sure I'm not telling you wrong. Yeah, so your 10 to the X button, and then that'll open a parentheses, and then make sure you put the negative in there. If you get a big huge number, you didn't put the minus in there. Okay, so you got to put that minus in front of whatever the pH is. Okay, So 10 to the x in parentheses minus 8.5. Basically, you're saying 10 to the minus 8.50, and that's when the calculator does that, it's going to give you that 3.2 times 10 to the minus 9. All right, and that's 3.2 times 10 to the minus 9 molar, okay, which is going to give you a basic solution. And just interestingly, in the body, various pHs, and it varies quite a bit in the human body. If you'll notice, where digestion begins to take place in the oral cavity, you have saliva, which is going to be between 5.8 and 7.1. In the esophagus, it should stay pretty neutral. It's going to get down in your bloodstream. Once it hits there, you've got to stay between 7.35 and 7.45. That's a very narrow range that you've got to maintain that in. In your stomach, you're going to be somewhere around 1.7 pH, 1.6 to 1.8. Then you are going to add some things in your large intestine to be 5 to 7. Neutral, and then you get a little alkaline in your small intestine, you're 8.5. So you're changing that pH as you go through to make sure you can absorb things and such as that. When it leaves the body in your urine, it can be anywhere from 4.6, which is acidic, to 8.0, which is slightly basic. And then your pancreatic secretions are going to be 7.5 to 8.8, and so the pancreas is then how you're going to raise that pH back up after it's been so acidic in the stomach.